Welcome back. All right, here's the deal. If you're given a system of three linear equations like this, already written out for you, just like this, you will have to perform what we just went through. You'll have to show me all the work that represents you understand Gauss-Jordan elimination. With that being said, if you're given an application problem, you're going to be allowed to handle it differently. And so I'll explain. If you recall, we looked at this problem in section 5.1. So if you want to get your notes out and look at this problem again from 5.1, that'd be a good idea. So all we're going to do is take that system of equations that was generated here, which was this. And again, we already worked this one out previously, so I'm not going to re-explain this. This is a problem from 5.1. Check it out. Now, with that being said, if this was just given to you fresh, like this is on a test right now, you would have to be able to read the problem and formulate this system of linear equations based on what you're getting here in the text. That's going to be the challenging part, all right? So because that's going to be the challenging part, we're going to handle solving this differently. And I think you'll enjoy how we solve this. So the first move is to translate this system of linear equations into an augmented matrix. So I'll do that now. There's your first row. And here is your second row. And finally, your third row. All right. So here's the deal. Because this is an application problem, I'm going to allow you to solve this type by using the row reduced echelon form function in your calculator. So what we're going to do is write RREF, and what your calculator is actually going to do is perform Gauss-Jordan elimination on this 3x4 matrix in like a split second, and then spit out the answer. So let's look at the calculator, and you'll see what I'm talking about. Okay, so for application problems only, for these larger systems, this is how you're going to be allowed to handle them. Go ahead and hit second matrix, and then go to edit. And our size here is a 3x4. Let's go ahead and enter in the entries. So 1, 1, 192, and then negative 1, 1, 1, 0, and then 1, 0, negative 3, 0. All right, so we've locked in our entries. Let's check those. I think they look good. All right, here's where the magic's going to happen for application problems only. Second quit. Go to second matrix. Go to math. And then scroll up to where you see RREF. Right there. Hit enter. Then hit second X inverse to go to your matrix menu. Matrix A. Here we go. Here it comes. Enter. And there's your answer. So now I'm going to take this information and put it on my paper. All right, so we now have our final matrix. It is in row reduced echelon form using this function of our calculator. So let's finally answer the question, because this is a word problem. So let's make sure we're answering the question or questions that are being asked. So therefore, I guess you don't need to put the 3 dot triangles there, but to represent the statement therefore, but whatever. So therefore we have 96, let's just abbreviate this, 1 bedroom units. We have what? 64 2 bedroom units. And we have 32 of the family style, 32 3 bedroom units. So make sure you're always answering the question that's being asked on a word problem.